Hi, it's Kipinlo Bates here, and as I'm walking through the forest to the place where my broken down car is to try to get it working and drive back home again, I thought a fun activity would be to try to describe how Ethereum works and what its components are at a fairly high level without skimping on technical details. And so let's begin. Ethereum is at its core a protocol, a set of rules and data structures and things like that everybody participating on it has to agree to, and they do that by running compatible software. There are at their core three different components on the current Ethereum blockchain, and those are Ethereum wallet software, validators, and execution clients. And I'm now going to move on to validators and execution clients because they have a large chunk in common with each other. The first thing to note is that they instantiate a peer-to-peer network. They are both pieces of software running on computers connected to the internet, and they have a peer-to-peer network protocol that allows them to find each other and swap data with each other. So that sets up the means for a communication network for the system. So now I'm going to go back to the wallet. The wallet is also connected to the internet, and a wallet is a store for private keys which you can use to sign transactions that are then associated with blockchain addresses that can be derived from those private keys. So a wallet is in a sense a password manager and a transaction generator. So if you want to do something on the Ethereum blockchain, you take your wallet, you use it to construct a transaction, for example, to make a call to a smart contract or to transfer some Ether or something like that. That produces a collection of binary data, which is your transaction. You sign it with your public key and you submit it to that peer-to-peer network. And the way that a wallet submits transactions to the peer-to-peer network is it connects to one of the nodes on the peer-to-peer network and says, here, I've got a new transaction, and that node will then broadcast that transaction across the network to all the other nodes. So now we have an unprocessed transaction that is stored in most, if not all, of the Ethereum nodes. And this is where validators come in. Validators package transactions into discrete parcels called blocks and publish them on the peer-to-peer network. But they don't just do that willy-nilly. There is a distributed random number generator that picks every 12 seconds which of the many validators out there gets to make a block this time. And that block has to satisfy all the rules of the Ethereum protocol. So it has to be properly constructed with the correct headers. It has to be digitally signed by the validator. The validator has to indeed be the entity that has been chosen at this particular moment to generate the next block. And the validator can put any unprocessed transactions into that block. And they do this because of a financial incentive, namely they get rewards for including transactions in blocks. They also get rewards for generating the blocks, and the other validators get small rewards for attesting those blocks, for agreeing that those blocks are correct. And this creates a chain of blocks of data, each block referencing the previous one, each one containing transactions. And so that is kind of the backbone of a blockchain, is this ongoing, growing set of data neatly packaged into cryptographically signed and correct blocks. So that's the validators. Now we come to the final part, which are the execution clients. Now, the execution clients don't validate in terms of generating new blocks for the system, but they do verify that the blocks that arrive have been correctly produced and that the transactions inside them are valid transactions that do the right thing and have been digitally signed to do that. And they extract the transactions and execute them in chronological order on a state machine that the execution client contains. And that state machine is called the Ethereum Virtual Machine, an EVM. And the EVM is kind of a virtual computer running inside the execution client, storing all sorts of data, balances against various addresses, smart contract code, the states of all the various different smart contracts, what data they are storing, and when they execute transactions, that will change some of that data, or add new data, or delete old data, and that changes the state of the Ethereum virtual machine, which is keeping track of the exact snapshot here and now as to who has what and what has happened. So you can get your EVM up to date by requesting all the historical blocks from the Ethereum nodes out there that have them, and running through them in sequential order, executing all the transactions on the Ethereum virtual machine, and that will get your EVM into exactly the same state as all the other EVMs out there. So all the execution clients are, with a little bit of wiggle in terms of propagation times across the network, all of them are in exactly the same state. They are generating one true view of the Ethereum world. All of them agree that this address has this balance, that address has that balance. There is a smart contract deployed to this address with this code, and it is currently in this state. Its variables have these values, stuff like that. And that is the briefest, simplest technical explanation I can give of Ethereum at this time, without delving really deeply into exactly how the bits and bytes are all bolted together and stuff like that. So if you grasp this, then you're pretty much going to be ahead of about 90 to 95% of people who are using Ethereum at the moment, and maybe it'll help you with some insights as to how the system works, and when things go wrong for you on Ethereum, exactly what is happening under the hood. I hope this has been interesting and useful to at least some of you, and I'll see you in the next video soon. Bye for now.